today we're going to talk about Amazon Aurora. My name is Aaron Hunter. I am a senior technical trainer with AWS training and certification. And with me, we have
Brian Terry. Hey, I'm a senior developer advocate on the CloudFormation team. And if this is your first time joining us, we're happy that you're here.
so happy. And we have chat moderators. So go ahead and throw your questions in the chat. You know what? Actually, do us a huge favor. Let us know where you're from. Throw your favorite emoji, all the things. So today we're going to bring a full day of Amazon Aurora, which is a database that service that offers 6 different database engines, fully scalable and highly resilient, performance intensive applications, all the different stuff and things. And we have some special guests with us. So let's see here. Who do we have first? Let's go ahead and pull this person up. Give me a second. I think it's Jared. Is that right,
Yeah,
Brian? Yeah,
yeah,
let me
it's
go
gonna
ahead.
be.
Let me go ahead and pull that up. So we have Dustin and Jared. Dustin, where are you at, Dustin? Let's see if we can get this in here. Dustin, hey, Dustin, welcome to the show.
To be here.
All right, and what are we doing here today?
Today we're talking about some kind of fun and interesting with the difference between what we call Aurora, RDS or relational database service and the other service built on top of RDS, which we call Aurora. Sometimes there's a bit of confusion between the two platforms, and we're going to get into a fun discussion over when to choose what, in what circumstances, what are some of the anti-patterns, use cases, and just understanding both platforms so that the DBA and organizations can make informed decision.
When to choose what? So like one of the different database options that we have, one of the offerings or engine types, right?
Right. Yeah. It guide you through the decision process of when to choose Aurora. When you have MySQL or Postgres, you can go the RDS route or the Aurora route. And some have great benefits over others, but only in certain circumstances. So we're going to deep dive into that a little bit.
You have some demos and presentations lined up for us too.
Yep.
Yeah.
Sweet. Can't wait.
Yeah, I can't wait either. I think this is a very super interesting service because my past life, I worked a lot with databases, specifically RDS. And when Aurora came around, this was like an exciting kind of new feature.
Yeah.
And specifically something we were looking for. We kind of tried to build our own. And I guess it didn't work out too well, but I'm glad you guys did.
Yeah, it really helps with modernizing enterprise applications and building SaaS workflows and applications too, I'm sure.
Oh,
Absolutely. Yeah, it really lends well to a microservice model and differing use cases for many of our different customers. So
Perfect.
Yes.
Let's go ahead and Dustin, do you have a slideshow that you want me to pull up for you?
yeah, that'd be great if you could get that on the screen. We can get started.
There we go. RDS or Aurora.
All right. Well, thank you, Brian. Thank you, Aaron. I'm really grateful to be here. Really grateful to have the opportunity to talk a little about something that I'm passionate about, and that's databases, especially helping enterprise and small businesses move to a database managed service. The opportunity to streamline and become efficient in our technology organization, and more specifically in the database realm, which sometimes the database gets left behind. It's complex. It's highly risky to make changes with databases, and I'm really excited that Aurora and RDS are here to help our customers migrate to the cloud in the most efficient and most performant way possible. And so today specifically, I meet with lots of customers and discussing their work patterns, their database flows, their application scaling needs. One of the most common questions that I get, well, we have this Aurora database platform, and you also have RDS, and sometimes the terms are used interchangeably. And so sometimes there's confusion on which platform would be the most appropriate for your workload. And so today we're gonna dive into that a little bit. We're gonna talk about RDS, what it is, what Aurora actually is. We're going to give you an overview of the two services, some of the specific Aurora features that you may be interested in as an organization. We're also going to talk about some of the Aurora do's and don'ts, and the Aurora anti-patterns that you want to stay away from when you're looking to migrate to Aurora. Then we have a couple of tables and a couple of decision matrices that will help you decide when I should actually use Aurora, when I should look into RDS and some of the features that might be beneficial to you. And so many of you on the call are very familiar with Amazon RDS, or otherwise known as Relational Database Service. It's a managed relational database service with a choice of 6 popular engines. And so when you're going to choose a database engine, the typical DBA these days would like to have it easy to administer, be secure and compliant, available and durable, performant and scalable. And that was the idea when RDS came about. It was built by AWS as a way to help customers reduce your complexity in supporting these critical transactional applications by making it easy to set up and operate and scale a relational database in the cloud. The main goal is to reduce your time consuming administrating tasks such as hardware provisioning, database setup, patching, and backups, all at the same time, giving you an opportunity to be cost efficient and have a resizable capacity for your database. And so we introduced Amazon RDS, which offers these 6 different engines. So MySQL, PostgreSQL, MariaDB, SQL Server, Oracle. And we typically refer to these as RDS SQL Server, which is, as an example, is it's still the same code, it's still the same software base underneath, but we have this great wrapper and automated process surrounding the platform so that it's easy for you as the administrator to administer. They include automated backups as an example, built-in replication, highly redundant. We'll talk about that a little bit more. So we have RDS SQL Server, RDS Postgres, RDS MySQL, and then and RDS Oracle. And some of them have their own nuances, but the same RDS features you can expect across the board. And then on the left-hand side, you might see where it says Amazon Aurora. What is that? And so we're going to talk a little bit more about that and how it can help you scale your database and your environment to beyond your wildest dreams. It can help you really scale out and get your customers and yourself
beyond your wildest dreams. Yeah, I'm sure that's really important for customers to be able to scale, so that way they can meet their application needs.
Yeah.
As you're able to scale higher and higher with Amazon Aurora, it opens up great possibilities for unlimited scale. And so we're going to talk a little bit more about the difference between RDS, Relational Database Service, and Aurora. So just some quick definitions. So Amazon Relational Database Service is a collection of managed services that makes it simple to set up, operate, and scale databases in the cloud. Aurora, and some people might not know this, is actually built on top of RDS, but Aurora is designed for unparalleled high performance and availability at a global scale with full MySQL and Postgres compatibility. Aurora came about due to the needs of being able to scale a relational database greater than what has ever been seen before. It actually employs a decoupled storage system that is deployed across multiple availability zones and allows a shared storage model on top of that Aurora sits on top of. So you can have multiple clusters, multiple instances, and it's fast, reliable, performant, and highly available because of that shared storage model. And going back to these 2 definitions, we have RDS and Aurora. Oftentimes, we will see customers choose RDS PostgreSQL or RDS MySQL. And then other times when they need to have a really performant database, when they need to have advanced features such as fast database cloning, up to 15 replicals, have a global database presence, they might choose Aurora. And when you're choosing Aurora, you want to make sure that you have your your query design patterns and the use case understood when you go to begin your testing, and to ensure that Aurora is going to give you that scale that you're hoping for. Both of these platforms, both Aurora and RDS, customers are able to spend time innovating and optimizing their applications, performance and capabilities instead of these operational headaches that DBAs were used to. As a DBA myself for nearly 20 years, I understand that the quickest way to get in hot water with your organization is to not have backups for your database.
Oh, those snapshots are so important, I'm sure. And
Yeah.
didn't we just release a new feature yesterday where there's 20 concurrent snapshots per region now?
That's right. I just did read that. You can have quite a bit of that DR capability now,
Nice.
and it gives
Yeah.
you that peace of mind as that DBA to be able to um, have those backups with at a point in time restore capability. So if I want to, let's say a DBA, a rogue DBA, or a person who maybe shouldn't have had access to the database, or just a simple mistake, somebody deletes data, you actually are able to restore back to that 5-minute window. So let's say last week, 3 weeks ago, somebody deleted quite a bit of data. Well, you can restore back to that point in time. This allows you to not have to worry about taking transaction log backups for those SQL Server DBAs. That's taken care of for you behind the scenes with a quick console to be able to go into, right-click, restore, or use the Amazon AWS CLI, which is our proprietary scripting language, so that you can actually automate the restore process or the backup process, or other processes that might take you outside a little bit further of the automation that's available. You'll see on the left-hand side here, you have the administrative tasks that you're still responsible for in the Amazon RDS or Aurora world. You're responsible for the schema design, the query construction, the query optimization. AWS now takes care of the automatic failover, the backup and recovery, the isolation and security, the industry compliance standards, push button scaling, so being able to scale your instance up and down, automated patching, advanced monitoring, with 3 different monitoring platforms included inside of this, and then also for the routine maintenance of the hardware and to some degree the operating system, and to some degree the database patching. And so what we're trying to accomplish here, if you learn nothing else, is this takes care of these time-consuming tasks that we don't want you as the DBA to focus on, so that you can focus on more important things, such as really optimizing the database, automating that infrastructure, and helping those developers reach the most optimal goals. It also lends well to like as I mentioned before, a microservices model, and it allows you to integrate into the rest of the AWS ecosystem with such services as S3 storage, AWS Lambda, and many others.
Yeah. And I am right for its permissions and
Yeah, I am.
Yeah.
Yes, yeah, identity access management, the AWS security layer that allows users and roles to authenticate.
You can use KMS or key management service for your data at rest encryption as well.
Correct.
Yeah.
And
Yeah.
it protects your data both in transit and at rest. All of those are included inside of the RDS platform, and that's what we're going to talk about a little bit more too. Is what is the difference in these services? What is security the same? Is am I highly available in both platforms? What are the key differences there?
And you mentioned keeping yourself out of hot water with the company, so all of that helps you.
Yeah.
Yep. That is the quickest way to get in hot water, is to lose those backups, or to have that downtime. And that's what AWS has built the service behind, is to be able to help those organizations alleviate those concerns. And I actually had a customer call yesterday where the customer asked me, he says, well, you're asking me to turn my keys over the kingdom, essentially. I'm now trusting you with my backups. How am I supposed to trust you? And I thought it was a fantastic question. It was a great question. It's like, yes, DBAs and organizations that manage their own databases have built fantastic processes and automated procedures to ensure that they have their backups available. And why should I trust you? We actually got a very interesting discussion about the process of earning trust and building trust. And we highly encourage that you test your product on our you test our databases and understand that high availability, understand that DR strategy, understand the processes that go behind this. Typically, customers might spin up a POC. They might create a one or two of their lighter weight applications and port it over to to RDS or Aurora, and they'll be able to build those migration muscles, earn that trust with the service, and say, hey, this actually works really well. In our tests, we've been able to actually restore these databases. It's going to a point where we've actually built some trust, and then you move the rest of your infrastructure over. And we've seen that time and time again. And that's part of this first session, is to help build that trust in helping you to decide what database is right for you. And we don't want to just push Aurora. We don't want to just push RDS. We want to make sure at AWS that we're being customer obsessed, right? We want you to only have these products if they make sense for your environment.
Yeah, that initial proof of concept, or that POC, is probably critical to have that discovery between the customer, their needs, and their customers' needs, as well as our product teams and the services that we offer.
Absolutely, and that goes into another topic of these services that we've built with RDS and Aurora. They are built from the ground up, meaning and backwards from the customer. And so we see when I meet with customers and they say, hey, actually, we weren't able to adopt AWS because of this reason. We weren't able to, or we're having a particular problem with this product. One of the goals that we have as SAs, if I'm being very open, is to work with our product team to say, hey, our customers want this feature. They want us to move in this direction, and we don't currently offer that. And so every time that happens, the product team base their changes and recommendations and new features based on customer feedback, which is really exciting to see those changes continually come out. Every quarter, we're seeing new releases. As you said yesterday, now we can do those 20 snapshots.
We're always innovating for our customers, for sure.
That's right.
Hey, Dustin, I have a quick question. So say, for instance, we're talking about this testing phase of databases. Say if, a company say my company went off and we tested RDS, and we kind of like RDS, but we wanted to kind of transition to Aurora. Is that possible to go from one to the other?
Yeah, and that's what we're going to get a little bit going to talk about and get into quite a bit of depth. Is what does that actually look like? Can I just migrate straight from my on-premise Postgres instance to Amazon Aurora Postgres compatible? Can I do that with MySQL, or would I want to go the RDS route first, or would I want to go to an EC2 instance and do self-host or self-managed for a little bit? It depends on often what your current situation is, but we see many customers in my day-to-day dealings with customers. We see them go straight very quickly into the Aurora platform. But again, it does require some of that testing and that POC to be built up to ensure that you're going to see the most optimal workload.
Absolutely. Cool. Yeah, so I love it how you can you test it out a little bit and then move to maybe something like Aurora or something. You just don't have to jump in. You can kind of figure out what works best for you, and you can do this with POCs. I think that's pretty interesting.
And that's exactly what, as a solutions architect, right? That's what we're here for. Is we're here to help give that prescriptive guidance, and happy to get on a call with any of our customers and help define some of that success criteria that will allow you to feel, hey, I'm confident in this product now. We've answered these questions that we had, and sometimes it helps a great deal to write those questions out, have those purpose-built tests, feel comfortable in the product, and move over. And one of those things that you're going to do when you're testing for Aurora is to try to build upon the features that are there and to have them work for you. So Aurora MySQL and Aurora Postgres compatible relational databases are built for the cloud. Their performance and availability of commercial databases, and it can offer you an opportunity to have 1/10 of the cost of traditional databases. And how we can achieve that is something we're going to talk about. You've got your performance and scalability. So you can go several times faster than standard RDS MySQL and RDS PostgreSQL. We're going to talk about that. You can have up to 15 different replicas, read replicas of point and click, near instant access to up to 15 different read replicas. highly available, fault-tolerant, self-healing storage, which is what we're gonna go over in depth a little bit here in a minute or two.
And those read replicas are scaled across multiple availability zones, right?
Scaled across multiple availability zones. In Aurora, we're actually copying the data 6 times over across at least 3 availability zones.
And that helps with performance and high availability to make sure our application's available.
Absolutely, and that ties into that shared storage model that we were talking about before, and how it's according to the instance of the cluster, all it sees is one large storage that it can connect to across these availability zones. It allows for these replicas to be true dedicated reads, where the writes aren't actually going to the replicas, because it all is truly just one storage. And then the last,
Amazing.
of course.
Thank you.
Yeah. And then the last, of course, is just a fully managed experience, managed by Amazon RDS. No hardware provisioning, software patch-up configuration, or backups are required. So we asked the question, who is adopting Aurora? I've found, and our research has found, that customers migrating from open source DBs are adopting Aurora, who want higher performance, better availability and durability, an easier migration plan, no application change. We talk a lot about refactoring in this industry, where we're having to go from one database platform to another. If you are on PostgreSQL or MySQL, you're able to migrate without any code changes. Customers who are also using commercial DB engines such as Oracle or SQL Server are able to migrate over, and can see up to 1/10 of the cost, as we talked about. And we call this database freedom, because you don't have any more licenses. You get similar comparable performance and availability, and even greater read and write performance is possible. And then we also provide migration tooling and services, which we have our database migration service. We have our schema conversion tool. So if you have a SQL Server and you're wanting to migrate to Aurora PostgreSQL, you have the option to use our tool to help you convert some of those procedures and let you know the level of effort that's going to be required. And then customers building new applications. One of the most exciting things about Aurora is the opportunity to adopt this microservices model that we talked about before, where it allows you to integrate with other AWS services. Use the database platform that works for you. And what we're going to be talking about in a little bit is, why does RDS make sense? Where does Aurora make sense? And you also have the opportunity to look into other NoSQL platforms, such as DynamoDB. Which we're seeing often customers migrate to both a NoSQL option and a relational option, decoupling their database into those the most appropriate database platform for their needs. Then you've got so this is a traditional database architecture. All the DBAs listening to this stream understand that databases are all about I/O, right? The design principles over the last 40 years are basically found in these two segments here: increase I/O bandwidth and decrease the number of I/Os consumed. This is the goal of a developer. This is the goal of an administrator, so that you can get the most bang out of your buck. Typically, we see the compute node sits on top of in conjunction with the SQL, the transactions, the caching, and then the logging. And then you have this attached storage sitting in your data center. Compute and storage have different lifetimes, of course. Instances fail and may be replaced. Instances are shut down. Instances are scaled up and down. Instances are added to the cluster to scale out. Compute and storage are best decoupled for scalability, availability, and durability. And with Aurora data, which is probably the biggest thing to understand, and what I wanted to spend a little bit of time on here, Aurora data is actually stored in the cluster volume down here. And as you see, it spans these multiple availability zones, as you guys mentioned before. A cluster volume consists of copies of the data across these 3 availability zones in a single AWS region. Because the data automatically is replicated across availability zones, your data is highly durable with less possibility of data loss. This replication also ensures that your database is more available during a failover. It does this because the data copies already exist in the other availability zones and continue to serve the data request to the DB instances in your cluster. The amount of replication is independent of the number of databases in your cluster. And through this technology, we are able to synchronously commit all of the transactions and the data changes across the availability zone, so that if you have well, we'll get there. I'll just move up to the slide here.
It seems like that's kind of what we were talking about earlier, talking about the different availability zones for high availability, and then you brought it up on the screen real quick, and we saw this availability zone failure, or maybe accessibility to that availability zone becomes restricted for some reason. So Amazon Aurora can help manage some of that overhead for us as well.
Correct, and it does that all behind the scenes for us in an automated way. It actually uses what I have on the screen here is the quorum model for writes and reads. So it gets confirmation across 4 different copies out of 6 for writes and 3 out of 6 for reads before the transaction is actually committed. So it's essentially highly durable and writes in a guaranteed manner across these availability zones. It maintains write capability if an availability zone fails, and it maintains read capability if an availability zone +1 storage node fails. One of the great things about this is that it's a self-healing architecture, and it rebalances hot storage nodes, rebuilds segments from failed hardware, and it uses a peer-to-peer gossip protocol, and is used for repairs. And so let's say your availability zone 3 goes down, and this database here is having, or this part of the database storage goes down. It allows for the other two availability zones to take over because the data is already actually copied there. So you can have up to 16 different DB instance nodes in a regional cluster, and these are spanning multiple availability zones. One would, of course, would be the primary, and the rest are considered to be what we call read replicas. And we'll talk a little bit how the read replica technology works. This is actually on synchronous copy between the availability zones, and when we say the transaction is not committed until it is written to these to at least 3 or 4, depending on the write or the read. It is not committed until those are actually copied across availability zones. And so it is asynchronous with an RPO of 0. And then again, it's a managed DB service. And so you have up on the screen here, we have the cluster, which you have your writer. And let's say your writer lives in availability zone 1. And you've also spun up a couple of read replicas. You've got your read replica right here and another one in availability zone 3. And then you actually are given what we call a reader endpoint that you can pass to your application for your read-only traffic. Your cluster endpoint would be given to any write or read-only traffic that would be appropriate to have on the same instance on the writer node. You can significantly reduce your volume on the writer by supplying this reader endpoint to your application, and it will then do a round robin to each of the readers for its read-only requests. So tolerating compute failures, so any reader node can be promoted to the writer primary. This is why it's important to have put a little bit of thought into where you're going to be putting your read replicas in different availability zones. It's automatically cached across these 3 availability zones. However, you do have the opportunity to put a failover tier favorite to determine the preference of failover for reader candidates. Lower values are more preferred for the failover. And failed instance nodes will be replaced after the failover and come online as readers. And then writes and asynchronous readers. So this is what I was talking a little bit before about synchronous versus asynchronous. So the storage is log structured in Amazon Aurora. Aurora doesn't flush data pages or full blocks to storage, and you can imagine the performance increase that we can receive because of that process. So redo logs, otherwise called the change vectors for data pages, get streamed continuously to the storage nodes by a writer, and this is all done in parallel. The read view logs are also streamed to readers for the buffer pool and read view updates. This technology allows you to have a low reader lag of typically less than 20 milliseconds across these availability zones. Now, you may have a question. You say, I thought you said this was a synchronous commit. It actually is synchronous, and it does allow for that 0 RPO in the event of a failover. The replication, however, does have this minimal lag to ensure that the correct data is actually returned with the system. But typically what we do see is that less than 20 milliseconds. Now, of course, best practices for replication and for when you're replicating data, you got to keep those transactions short and as short as possible so that you're not causing that blocking or locking or lag across all of the systems. Because if you're not updating on the primary and you have other processes dependent on that, you can see that replication delay. So it doesn't excuse the proper dev principles that that you should be following as well. And the autonomy of the Aurora compute node, and this is an interesting topic. I felt it was good to spend a minute on. So the DB engine process interacts with the storage driver for data persistence. The storage driver then interacts with the storage subsystem. The page cache is independent and is survivable in the event of process crashes, which is what allows it to be highly available as the nodes would fail over in the event of an availability zone disaster or failure. And then it's also important to note that temporary storage for temp tables, log files, and sort files are actually held at the local level. And so when you're creating your Aurora instance, it's really important to provision the local temporary storage or ephemeral drives so that they have enough to handle your temp DBs, your temp processes and sorts and things of that nature. That actually doesn't happen on the cluster storage volume itself. So it's decoupled from that perspective. And then again, with Aurora, read replicas are dedicated to reads. So if you look on the left-hand side of the screen here, we see that traditional read scaling, usually a single thread or limited parallelism. It uses logical using binary log or wall log replication. So binary log for MySQL or wall log for PostgreSQL. And this is where I find this technology fascinating, and you can really see the benefit. When you have a replicated system using wall log technology on, say, on-premise or EC2 PostgreSQL, you're actually writing to the writer, and then behind the scenes, it's actually log shipping those logs to the read replica, and it's writing them all over again on the read replica. So you're seeing that same I/O. It's independent storage, it's decoupled storage. In Aurora, we're using using page change vectors or the redo log. And what that means is we're not doing any writes on the replica. Your data is there, it's committed, it's fast. You're not waiting for those IOs to be, for those transactions to be completed, which significantly reduces the latency time. And again, one thing to really remember is this is a shared storage. As you can see over here, we have this data volume from one instance to the other, from one database to the other. Here we have the shared multi-AZ storage. So there should be no difference between what's on primary and then what's on the reader.
Yeah, it's shared and distributed, right?
Distributed across all of those availability zones, across
Yes.
all of those 10 gigabit chunks, which is what we the previous slide was showing. Yeah. And then, like we said, the shared storage, and it uses common MVCC states, efficient for OLTP reads, and it's safe for ad hoc, long-running, or risky queries. Now, you may have less of a performance benefit on Aurora for using ad hoc and long-running or risky queries, but it is certainly safe to do so and can be very performant there.
But what if we have, let's say, some high IOPS? Is there a way for us to monitor that and maybe adjust?
Absolutely, and that's actually something we're going to talk about in a couple of slides. We're going to talk about the need for monitoring your Aurora instance to get that best bang for your buck, because there is a different pricing model. And at AWS, we're very concerned about customers spending needless money. And we've architected this system so that our customers are able to monitor in an efficient manner to help them say, hey, these are some of the changes that we can make in order to reduce our I/O, reduce our storage consumption, and thereby reduce I/O.
That's
And
great because cost optimization is literally one of the pillars of the well-architected framework. So great to see that we're
absolutely,
aligning to that.
yes. Um, Another interesting, this is a comparison with Aurora IO profile. You can see the Amazon RDS MySQL multi-AZ, Amazon Aurora MySQL on the right-hand side. This diagram goes over the process of how it uses Amazon Elastic Block Store. It does has an EBS mirror, which is EBS is our storage under the covers, and then it has the standby. And through this testing benchmark test, the sysbench test that we ran, we were able to get 780,000 transactions for 30 minutes in Aurora using the distributed write technology, the writes and how the readers were going across the board. We were able to actually show 27,000 transactions, or 35 times more queries were able to be processed, and at a less, so average 7.4 IOs per transaction, and then 0.95 IOs per transaction. So yeah, under the right circumstances, yeah, very powerful. Under the right circumstances, Aurora can blow right at Community Edition right out of the water based on this storage architecture. Let's just do a quick time check. Okay, so we talked a lot about readers. I'm gonna skip over that. So this is a useful Venn diagram that I feel would be appropriate to share. I wanted to really focus on Amazon Aurora being, the term RDS and Aurora sometimes are used very interchangeably. We have two very similar products in some regard. And you'll see in the middle here that with both of these products, you're getting automated patching, you're getting automated HA, you're getting the automated backups, the isolation and security, the industry compliance standards. These versions of MySQL and Postgres are actually supported and compatible on both of these. You get the push button scaling, you get the monitoring, the routine maintenance that comes with that. So, okay, as the DBA, I get all of this stuff. Why would I choose RDS over Aurora? Well, the first thing that we talk about and that I point out is the shared storage model. This offers a more enterprise experience. It allows you to have that lower transaction latency across your primary to your readers. You can have up to 15 read replicas in Aurora. We offer millisecond latency due to the nature of the shared storage and the distributed transactions. We offer something called global database, which is a low latency opportunity to replicate your database across different regions across the world.
And actually, on that, so we have a comment from LinkedIn from Jose asking, what about the writer nodes and scaling horizontally? So we're talking a lot about reader nodes and accessibility and high availability there, but can you comment on the writers?
And so the Aurora storage subsystem, something that makes it very powerful as well, is the opportunity to do this log-based type of storage, and it allows for up to 1/8 of the writes down to the subsystem, which means that you're going to be writing to the disk 8 times less than on average than you would be with MySQL and PostgreSQL, and that actually is a big cost benefit, because with Aurora you're actually charged with I/O. With writes, we typically see that you have one writer, one primary, that would and then you have your readers span out across multiple regions with global database.
Awesome.
There are some options to do a multi-master MySQL, but typically we see the global database presence as read only.
Yeah, and having that multi-primary, I'm sure, is probably important for some customers too, in order to have increased accessibility and failover. Thank you so much for answering that. And Jose, hopefully that answered your question. Let us know in the chat if it did. If anyone has any additional questions, please type them in the chat. We are watching.
PostgreSQL and MySQL, we can see a large performance increase with 5 times the throughput of MySQL, 3 times the throughput of PostgreSQL. These are through those standard sysbench tests and benchmark tests that when those studies are published. Optimized throughput, as I mentioned, and one of the questions that we were just asked, the writer, how does that work? Well, with the optimized throughput, we're able to speed up the process to write to the disk through that throughput, and we're going to that disk storage subsystem on average 8 times less. Now, this is where I'm gonna go back to this one, designed for, and I'm gonna switch over here to Amazon RDS, and you can see some of the benefits of RDS, where you can have up to 5 read replicas, and you can see the difference between 5 and 15 over here. We're talking latency in seconds. Over here, we're talking latency in milliseconds. Sequential workloads work like they normally do on Aurora. Excuse me, like they do on your typical standard implementations of databases, which actually don't suit well for Aurora. Aurora, you're going to get more bang for your buck down here where it says designed for queries that run in parallel and for highly concurrent workloads. You're going to see Aurora scale a magnitude greater when you're really pummeling it with queries that are running in parallel or highly concurrent workloads. It's not really designed for sequential type of workloads. Like as an example, if you put a process in a for loop and you're running the query over and over and over and over again, that would not scale as well in Aurora, and may, in limited circumstances, some circumstances could even cause a performance degradation, which we've. So as you can see, sequential workloads probably not the best fit, which we'll talk about some of the anti-patterns for Aurora. The billing side of things we'll get into a little bit more about how you're billed on RDS versus Aurora. RDS is built for standard database performance. Again, it's what you're used to with your EC2. It's what you're used to with on-premise. We do offer a cross-region read replicas that are more limited in comparison to global database, and we'll talk a little bit more about that in a minute. And so some of the aspects when customers are choosing to go to Aurora or RDS would be to maintain a one-to-one compatibility with open source products. RDS attempts to release new minor versions within 60 days of the community release for MySQL or Postgres. Sometimes exceptions apply, but for the most part, that is very true. If you desire simplicity of managing open source databases across multiple cloud providers, RDS is a great fit, typical of SaaS providers, as was mentioned at the beginning of this talk. It does not require, if you do not require advanced database features and can keep costs lower on RDS with single AZ and GP2 storage. So if you have a test environment or a really low requirements of downtime, or if the application is less critical, and you wish to put it on single AZ, so where you're not replicating across 2 different availability zones, and many circumstances warrant that, right? It's not a best practice for enterprise or for OLTP customer-facing databases for the most part, but this is definitely a way to keep costs lower and perfect for the RDS platform. With Aurora, it's for customers who require additional scalability, such as the possibility of needing to read from up to 15 readers within a single region, or being able to scale up to 128 terabytes of storage. You want to take advantage of enterprise-grade features such as fast cloning, fast crash recovery, parallel query, serverless technology, automated backups, higher SLAs, etc. Serverless technologies is something actually that Jared's going to be talking about in the next session or two. And so we'll talk about Aurora Serverless then. Then if you need out-of-the-box disaster recovery capabilities like Aurora Global Database, Aurora Global Database is there so that you have an opportunity to fail over your database to, let's say we had heaven forbid, a disaster on the East Coast and it took out the entire region. You would then be able to fail over your instance to another region in a very timely manner. So that's one of the benefits of Aurora Global Database. You can also use that as a read-only for your users who are in another region.
We have a comment in the chat saying Aurora is huge. That is impressive. It can do a whole lot for our customers. And actually, there's another question asking about the max number of secondary databases for fault tolerance. So we mentioned it earlier. Maybe they didn't see it, but can you touch on that again?
So yeah, it's actually this is a topic that can go into a very deep dive session. The instances are in a way not really relevant to the disaster recovery or to the high availability aspect, because the storage layer is shared across all of those availability zones. And what Aurora does is it actually segments data into 10 gigabyte chunks across the disk. And then it copies those 6 times across each availability zone. And so you have this capability to create clones, to create new replicas based on already existing storage. So it allows for that high availability that's decoupled from the instance. And so you can have, let's say, 3 replicas throughout each availability zone, and you can add a 4th or a 5th or a 6th, and you're going to get that same that same performance and high availability regardless of the number of replicas that you have. The only requirement is to have at least 1 replica per availability zone so that you can fail over to those different to those different replicas. Yes, Aurora is very large. You have the opportunity to store massive amounts of data. Most of the customers that I deal with don't approach that 128 terabytes of storage. I have seen it a few times, and we've had to come up with some unique situations to allow them to continue on to even scale above that. But for the most part, it's very, very large, very fast, very performant for the large databases that customers needs. Hopefully that answered that question.
Yeah, I think so. Thank you so much. There's another one here. Not sure if you're going to cover migrating at all, but if you are, there's one question about migrating from one account to another. So we're talking about on-prem migration to AWS cloud, but what about account to account?
So account to account replication is interesting. It requires a little bit more thought. The nice thing about Aurora and RDS in general is that you have a lot of the same built-in features that allow you to use native Postgres, native replication technology, such as with Postgres, the wall log technology, or with MySQL bin log technology. So you can migrate using those type of those native services. You can also migrate using a snapshot and restore. That of course would come with a little bit more downtime, but with using the bin log replication for MySQL as an example, you could replicate and fail over that would consist of downtime for just the failover purpose. So there's a few different options. We also have another option called database migration service, which is an AWS service that helps migrating your actual data to a different account, to a different region, to a different anywhere else in AWS cloud. And that can be done from on-premise to the cloud, or from account to account, or region to region, or whatever your particular use case may be. Database migration service is very popular, and once it gets going, it's very easy to use and allows you to start and stop the replication. It allows, if an instance fails, you can scale the workload so that you can be doing multiple threads at one time, to be copying multiple data at one time across from account to account. I see this quite often when we're migrating with customers. When customers a business is acquired by another entity and they need to migrate all of their accounts all of their databases or AWS resources to another account. And so this is the preferred method that you would use to
Awesome.
do
Thank you
that.
so much.
Yeah, great. It looks like we have another question coming through.
Sure.
So, what is the maximum capacity in terms of IOPS, throughputs, etc., for Aurora MySQL for larger R6G family types? So I guess
Say
this
that
is
10 times fast.
I know. So I guess
What
he's
type?
looking at the
What were
maximum
the
IOPS.
instance types for the question?
Yeah, so I guess he's basically looking in terms of what is the maximum capacity for IOPS for the R6 family from servers.
Off the top of my head, I'm not sure. We'd have to look
Yeah.
at the specs for the R6, but essentially Aurora offers near unlimited IOPS, right? It's that's kind of the difference between uh, RDS and Aurora, where RDS storage you have a max size of 64 terabytes. With Aurora, you have a max size of 128 terabytes. With the IOPS, you can choose one of two different type of storage methodologies. One is GP2, the other is provisioned IOPS or IO1, and that allows you up to 80,000 IOPS. But this is not typical of the IOPS that you would use because it requires a one-to-one ratio between the size of the volume to the size that your IOPS are allowed to put through. GP2 on RDS is probably our most popular option with our customers because it allows you to scale up to 3,000 IOPS up, and you can burst up to 3,000 IOPS regardless of the storage size. If you need to go higher and have that dedicated, that's when you would go to provisioned, which depending on your particular use case can be more of an expensive choice.
And GP2 is a volume type, right? So there's
Correct.
IO1, GP2. Okay.
Yeah, it's a storage. It's more a methodology. GP2 is it allows you to burst up to those 3,000 regardless of the storage size, and provisioned is for more of an enterprise database where it needs to scale. And so you would pay for, let's say a customer would come in and say, hey, we need 10,000 IOPS for this database. And you would provision that much. And the negative aspect of that is that you would be paying for that even if you don't use it. Where with Aurora, you're only paying for IO that comes through. One of the things that's really cool about Aurora, and this goes back to that monitoring conversation, is if you're monitoring your database, you want to make sure that you're monitoring anytime the disk subsystem gets a query written to it or it's read from disk, because that's when you're getting charged with Aurora. And the more you can keep your queries in cache, the less you're going to have to pay for it. And if we go back to that pricing model here, let's see, yeah, and you can have a large potential cost savings for your appropriate workload. And I'm just going to skip to this part because I know we're getting short on time here. These are the two slides that are pretty important. I'm going to start with this one. These are some of the best practices that you would use when using Aurora. You would want to monitor your workload based on that conversation we just had. Aurora bills at the storage IO layer for the largest portion of the bill. Keeping tabs on queries that go to disk versus memory can save lots of money. You want to set your TTL value of less than 30 seconds. This will reduce connection failures. You want to test your DB failovers. You want to understand how long the process takes for your use case. You want to use cached workloads. Because if your data is going to the query to the cache, then you're not getting charged. You want to allocate enough RAM, as I mentioned above, and then you want to keep your transactions short because the quicker you can get in and out, the quicker you're going to be, the less you're going to be charged for it. This will also reduce replication lag and give the query the best chance to stay in the cache and not go to disk. And then one of the slides that I like to go over with customers when I'm talking about Aurora is that this is the patterns and anti-patterns. So for Aurora, it works really well for OLTP workloads. An anti-pattern is massive data warehousing or OLAP type workloads. This is where you would consider more of an Amazon Redshift product. A good pattern for Aurora is high read traffic when you're reading a lot of data at one time, and using those highly concurrent workloads. If you're having those large writes and large reads that come in concurrent and in parallel, that's when Aurora is going to scale and outshine and leave the competition behind. Document management is not a good pattern for Aurora. Using sequential workloads are not a good pattern for Aurora. Sporadic workloads on large databases are not typically a good pattern. This is because you want to be going less to the storage subsystem, and if you don't have the query in cache, then you're going to be probably paying more for that query. Heavy
So I
join.
see document management, consider using document DB. Do you have recommendations for the other anti-patterns?
Sequential. So anything else that's not mentioned, RDS is also a viable alternative. Something that you would. So if you're on RDS and you're relational and you have sporadic workloads on large databases, you probably wouldn't gravitate towards Aurora, and you'd stay more on possibly on the RDS side. And this more becomes a function of not that it would necessarily perform bad on Aurora, but it's going to cost more. Your cost factors are going to be a little more risky with this type of a pattern. And so these last three are best practices, anti-patterns for relational databases like RDS, Postgres, or MySQL as well. They just will end up costing a little bit more in Aurora. And when you're talking about Aurora, you want to make sure that the forefront of your mind is the cost factor. How can we keep our costs low? How can we design our queries patterns to keep those costs low? The last thing we're talking about is long-running queries and how to keep those queries short in those OLTP workloads. That's why we say massive data warehousing with OLAP workloads might not be the best shift, because you're doing a lot of table scans in that type of an environment. And typically that data is not going to all be held in cache. And we talked about some of the best practices. These are great to follow when you're making decisions and going over to Aurora. And then, so the summary table, this is something that customers, you might find helpful, be able just to kind of show up to, like the read replicas, you can have up to 5 RDS read replicas, you have lag in seconds, you have native replication, you have MySQL bin log, Postgres wall log, in addition to those 5 built-in replicas that you can have. With Aurora, you can have up to 15 read replicas. It uses a quorum model, and we also offer a global database for that disaster recovery and cross-region replication, that low latency cross-region replication. Fast database cloning, which unfortunately I didn't get a chance to talk to very much, but you have an instant copy of the database at your discretion. You can have up to 15 cloned databases. This is very useful in a dev and QA type of environment where you want to give your dev instant access to a production database, but it grabs the storage from the already provisioned storage underneath the covers across the availability zones, and you have an instant copy of your database. And then
That's great.
The cost model and the use cases of highly concurrent workloads, parallel queries, and then for actually these are mixed. This should be down here. But, highly concurrent workloads and parallel queries. Make sure, the final thought is, make sure that when you're designing your workloads for Aurora, that you're going to use those highly concurrent workloads, massively take advantage of that advanced storage system on Aurora.
We have about 30 seconds left. Any final words for our viewers? And you have a lot of comments saying thanks for the presentation, thanks for all the information. So great job.
Oh, thank you. It's been a pleasure. I'm sorry, I wish we had more time. I do believe in Aurora as a DBA, I believe in RDS products. Make sure that you are designing your patterns so that you can save as much money as possible. These two systems are here for you, for those enterprise level workloads, for those parallel workloads, for those highly concurrent workloads. I think you'll be pleasantly surprised at how well Aurora can actually scale in those certain circumstances. But make sure to test. We want you to save money. We want you to test. Thanks a lot. Appreciate